If you want to know what a Monte Carlo simulation is and how to implement one in Python, then you're in the right place. A Monte Carlo simulation is a mathematical technique that uses repeated random sampling to estimate the range of outcomes for uncertain events. It helps in predicting results by simulating a variety of scenarios based on different input values. In today's video, I'm going to show you how you can implement one in Python. The thing we're going to be simulating in today's video is a retirement savings simulator. This article says nearly half of Americans have no retirement savings, and so it's important for people to know whether or not their retirement savings is enough to last them through retirement, and that's exactly what we're going to be using in our simulation today. We're going to take some inputs such as the amount that someone has saved for retirement, an expected rate of withdrawal, and we're also going to take in an average expected rate of return and a standard deviation, and we're going to simulate whether or not someone can survive in retirement without having to go back to work. Go ahead and open up your development environment. I'll be using a Jupyter notebook, but you can do this in any environment. The first thing we're going to do is we are going to import the libraries that we need to do our analysis. It's pretty simple for this video. We will just import numpy and use the alias np. The next thing we need to do is we need to define our input variables. So the first thing we'll need is our initial savings. This will represent how much does someone have saved for retirement. And we're going to use $1,000,000. Remember, in Python, you can use these underscores as separators just so it's easier to keep track of the number that you're inputting and making sure you're inputting the right number of zeros there. And we're going to specify withdrawal rate. This will be the percent of your portfolio that you withdraw to live off of each year. We'll set that to 4%. Typically in personal finance, people use this 4% rule, which says you can withdraw 4% and safely retire. But we're actually going to be testing this assumption, and this is one of the parameters you can play around with. The next thing we're going to need is a number of simulations that we're going to run. We'll set this equal to 1,000, but this is another parameter you can play with and do different experiments with. And we want to simulate a number of years. So 30 years can be a standard retirement. Let's say you retire at 65, you might want your money to last you 30 years. But people are living longer these days, so we're going to start off at 50, but this is a parameter you can play around with. The next thing we need to do is input our expected return. We're going to start off at 7%, but again, this is a parameter you can play with. Maybe if you're in retirement, you'll have a more conservative portfolio, and maybe 5 or 6 might be more appropriate. And we also need to input our volatility or our standard deviation of the returns of our portfolio. We're going to set that equal to 15%. Now that we have the libraries that we need and our input variables defined, we can go ahead and begin implementing our simulation. So we're going to store the results of each year in this list called survival year, so we need to define that. And then we're going to create a for loop, and for each simulation that we have in our number of simulations, we need to run the simulation. So we need to loop through for each of these num simulations that we have. We're going to use an underscore since we actually won't be referring to the temporary variable that we create. So we're just going to say for underscore in range, and then we're going to input the number of simulations that we plan on running this for. The balance here will be the initial savings at the start of your simulation, and we'll start off by setting the number of years survived so far to be 0 because this is the start of the simulation when they haven't gone through anything yet. And then we're going to iterate through each year that we have in our simulation. So we'll say for year and range years. So for each year that we want to run our simulation for, annual return will follow a random distribution. So we'll use this numpy.random.normal, and this will give us a random value from a normal distribution of which we pass in the mean and standard deviation. The mean will be our expected return, and the standard deviation will be our volatility. Now we're going to update our remaining balance and incorporate whatever our annual return was. So we're going to set our balance equal to 1 plus our annual return, which is our change in value, and then multiply that by our balance. Once we have our updated balance, we're going to apply our withdrawal rate. So we're going to use this minus equals, and then we will subtract the initial savings multiplied by our withdrawal rate. Just to recap, we're applying our change in portfolio value here, and then applying our withdrawings here. The next thing we want to do is we want to check is our balance less than or below 0. because if it is, we want to break out of our loop here. This means that the person has run out of money and they did not make it through all of their years of retirement with their retirement savings. If this doesn't execute, then that means they did make it through this year, and we can take years survived and add 1 to it. Now we can go back one level of indentation, and we'll take our survival years and we'll append to it the years survived for this iteration. Now that we have our simulation built out, we can pull some statistics. So we're going to get the average number of years that a user would survive from this retirement without running out of money. And to do that, we're just going to get the mean of our survival years. And then we're going to look at that. You can see that the average number of years that someone survived in retirement was 46, which is really good. If we compare this to a standard 30-year retirement, then most of the time this person would make it through with their retirement savings intact. Now let's see the percent of time that this would not work and this person would not make it through retirement. So we'll calculate our failure rate, and we're going to count up all of the times where they didn't make it at least 30 years. So we're going to use this array, and we'll pass in our survival years. And we're going to count the number of times where they didn't make it 30 years, and then we'll divide by the number of simulations that we ran. And we can look at our failure rate here. We can see that our failure rate is only about 9%, which means the person would make it through retirement with their savings intact 91% of the time, which is really good. So if we go back and look at our input variables, we can see that over 90% of the time of this particular configuration, this person would be able to make it through retirement at least 30 years without running out of money, and on average they'll be able to make it 46 or 47 years. You can tweak these however you want, and then even for your own particular situation to see with your forecasted retirement savings and rate of return, do you think you would be able to make it through retirement? Let me know in the comments. That's it for today's video. Make sure you like, comment, and subscribe, and click the notification bell so you don't miss an upload. I'm going to be posting a lot more Python data analysis videos, and also I'm going to be posting a lot more financial data analytics content. So if you like this video, make sure you subscribe so you don't miss that. If you like this video, I also just posted a video where I do financial data analysis on actual stock market data to find the best stock. Again, none of this is financial or investment advice. It's just educational content for you. But that's it for today's video, and I'll see you in the next one.